How to simplify rational expressions. Coming up, back into action. Hey guys, today we will be doing rational expressions or rational fractions, or I will give you another name for that. Sometimes it's called algebraic fractions. So basically it's the same thing. It's something that has top and bottom. So you have actually x expression on top, or other letter also could be used like y, a, b, u, whatever. And also you have your bottom expression that actually located on your bottom or denominator of your fraction. That's why another name for this rational expression is algebraic fractions. Now we will be focusing mostly on only one variable, let's say x, that your rational expression is made of. Sometimes your expression contains more than one variable. It could be x and y, it could be a, b, or it could be more than two, sometimes three or more. And I have another video on operations on rational expressions. How can we multiply, divide, add, and subtract them? When I will be doing expressions containing different letters, or sometimes it calls unknowns, so you could check it out later. But for now, let's say we have just one letter, let's call it x, that your expression actually is made of. Now, the most common problem that comes up with rational expressions is how to simplify them, or how to reduce them to its simplest form. Well, the process of this reducing or simplifying, it's very similar like what you do with fractions. And we always write the fraction into its simplest form possible or conceivable. So we normally do not write, let's say, 2 over 4. Instead of 2 over 4, we would rather write 1 over 2. So actually what we did, we cancel. We find out that 2 and 4, both of these two numbers, top and top, they're divisible by 2, actually, which is a greatest common factor or highest common factor, GCF, if you like. So, and we reduce our fraction by this 2, which is GCF. So since 2 goes into 2 once and 2 goes into 4 twice, we would be end up with something like a half, which is considered to be the simplest fraction for that fraction. So we got our fraction down into its simplest form possible. So that idea comes from elementary school, and this is a basic idea for all fractions. We always simplify fractions at the end of any problems we do. Now, the same technique and the same idea applies for algebraic fractions. So when you are given something like this, when you have your top and you have your bottom, which are not numbers, they are actually expressions in x. They are, you can call them functions if you like. So the same idea applies here. We want to get it down in the simplest form possible. So there are actually a pattern, some steps to follow, to keep in mind always. In the first step, you factor it. You factor your top and your bottom expression as much as you can, as much as possible. So by factoring, what do I mean by factoring? Well, actually, it's normal factoring. That means that you could spot and pull out the common number that your terms contains. It could be as well GCF, it could be number, it could be term. You could also factor out your quadratic expression, your quadratic factor if you have one. So for factoring quadratics, you could check out my video on quadratic equations when I did factoring, and I did factoring of quadratic. You could use different techniques such as completing the square, magic X, or even using a quadratic formula. So all these things actually come up here, and actually you need to know that stuff. Now, also the difference of squared can be also useful in this case, and later on I will show you how it works. Now, the first step, factor. Factor as much as you can, as far as possible. The next step, spot a common factors. Spot a common factors that belong to your top expression and to your bottom expression, and cancel it out. Cancel it out legitimately. So you don't want to do something like illegal. So everything has to be legal in terms of operations and this math. And about the last step, restriction, so I will get into this in a bit. Now, let's put it to the test. For the first one, when you have 9x plus 3 and 3x, 9 and 3, both of these numbers, they're divisible by 3. So you have this 3, which is common factor to both of these terms. So pull it out, factor it out front. So what's going to be left over? What goes into your parentheses? So when you pull out 3 from 9x, 3x would be left over. Now, what's going to be left over instead of 3? It's 1. And always at this point, you could check out your answer just mentally. It would take you probably a couple of seconds, but just to make sure that you can go on, and you at this point you didn't make any errors, any mistakes. So just factor it out, just FOIL it out, multiply it out back. So 3 times 3x gives you 9x, fine. And 3 times 1 gives you 3. Alright, at this point everything is fine. We factor it out correctly. Now, moving to the bottom. 3x, what I can do with 3x? Nothing. 3x remains the same. So there is nothing that you could do with 3x. It's just 3x. So just write it. And at this point we are moving to the next step. Cancel. Cancel the common factors if there are, because sometimes might be no common factors, so there is nothing to cancel off. So in this case you have this 3, you have the number, so this 3 and this 3 could be cancelled out. So just cancel out and you erase it from top and bottom, and you would end up with 3x plus 1 on top and x on bottom. At this point again, check to see if you cancel any more, if you cancel something else. No, you cannot. You cannot cancel x's, guys. You cannot, because for some people it might be like this tempting to they see this x and their hand like wants to just cross them. No, I'm sorry, but you cannot. That's not valid. It's wrong. You cannot cancel this x, because here you have addition and here you have just x. So you could only cancel a common factor when you have multiplication between your terms. For example, here, why we cancel? Why we were able to cancel? Because here we have multiplication. It says that 3 gets multiplied by this term and 3 gets multiplied by x, so that's why we cancel. Otherwise, if you have something like add or subtract, so cancellation is not prohibited, impossible. So this is your final answer. And we're done. We're done with the first one. And if you ask me about this restriction, maybe you would still kind of get worried about this. Don't worry, I will get into this in a right time. It's not the right time for this. Nothing to do else with this fraction, and this is your final answer. This is the basic, the simplest kind, I would say. Let's move on to the next one. Again, you start with top and try to spot the common factors. The common factor, the GCF, so that could be GCF, or sometimes it's called HCF, which stands for greatest common factor or highest common factor. The idea is the same. It's precisely the same thing. Now, x squared plus 5x. Yes, you have a common factor, x, and x could be pulled out. Just snag it out. What's left over? Instead of x squared, you would have just x. You keep this plus, and you have 5. Again, mentally, at this point, make it as a habit, like morning routine when you brush your teeth or when you take a shower. That's very good policy. So at this point, check x times x gives me back x squared. X times 5 gives me 5x. Done. Now, moving to the bottom. Very similar. You have quadratic x squared and you have negative 3x. X pops out at you. Take it out. So take it out, x, and place it outside of your parentheses. What goes inside? So x is left over minus 3. Alright. Again, x times x gives you x squared back, and x times minus 3 negative 3 gives you negative 3x. Fine at this stage. Now, you have x and x. Can you cancel x? Yes, you can. You can cancel x. It's different from that what did before. Before we cancel a number, it's okay, no problems. In this case, yes, you can. You can cancel x. But immediately after, I would write the restriction, and we kind of move to the third step that I mentioned before. Restriction or condition means that your expression is valid when this condition kicks in, works in. So provided that, so when we cancel this x, basically x cannot be equal to 0. Because when x is 0, your bottom becomes 0, and your fraction has no algebraic meaning. So after, when we cancel x, we would have just x plus 5 on top and x minus 3 on bottom. And At this stage, there is no x. And if you plug in this x equals 0 over here, you would have 0 plus 5. 5 over 0 minus 3, minus 3. So 5 over minus 3, which is correct, no problems. But when we plug in this x equals 0 here, we would have these division problems. That's why this restriction actually comes out. That's why you should write it. Now, this is my disclaimer. If you ask me, do I have to write the restriction or condition? It depends. Again, it depends on your teacher, your book, your exam, your question you are asked, you are given. Well, if you don't write, so if I get my answer like this without anything, it's technically correct. That's correct answer, that your first initial rational fraction is equal to that one. After when we cancelled off this x. That's technically correct. So you don't have to attach anything else. That's your final answer. But to be perfectly correct, to be precise, so you should write this x is not equal to 0, because it's not obvious. And again, when you have your final answer, it's not that obvious that your x cannot be 0. It's obvious that your x cannot be 3, because if your x is 3, it would make your denominator equals 3, equals 0. And you cannot divide by 0. But when you have, but it's not that obvious that your x is not equal 0. But here again, when we plug in x equals 0 over here, it creates this problem. It creates this division problem. And we cancel it. We erase it, this x equals 0. That's why I wrote it with a star. That means it's kind of optional restriction. So if your teacher doesn't mention anything about this restriction or condition that you have to write out, you have to attach to your answer, you could simply just leave it out and don't worry about this. But just keep in mind as a side note, as a pro tip if you like, that sometimes you are asked, and sometimes it states in your problem. So state the restriction, write out the restriction. So at that point, you have to do this, and you have to come out with this x. Sometimes it's not only one x, to be perfectly honest with you. Sometimes it could be more than one. And it always comes up when you do this division. So like make it as a signal for you, as a sign. Every time when you do cancellation with terms, this term that you cancel off, the terms would create this 0 problem, this division problem. So just spot it, identify it, and just pull it aside and write out this condition. Now, moving on. How about this one? So again, start with top and factor out as much as you can. 2x squared minus 2, both terms have 2, which is common factor to both of them. Pull it out, factor it out, take it out. So 2 has to be taken out. And what's left over? Just x squared minus 1. Now, for the bottom, 4 could be taken out. What's left over? Just x plus 1. Now, cancel. Ask yourself, can I cancel something? Yes, you can. Technically you can. You have 2 here and you have 4. And since 2 goes into 4 twice, you could do this cancellation. That's fine. Now, is that my final answer? No. Again, you could get back to your first step and check to see if any more cancellation can be done. If any more simplifying could be done. X squared minus 1. This is kind of quadratic. It's not a standard form, but it's difference of squares. And I mentioned it before, sometimes it comes out. So you have to spot a formula, you have to spot that this term basically could be factored out into 2 pairs of parentheses, and it's basically starting with x, and it's x plus 1 and x minus 1. Since 1 is a perfect square, so since 1 square is 1, so your x squared minus 1 can be broken up into 2 pairs of parentheses, namely x plus 1 and x minus 1. So you factor it out now completely. How about your bottom? You still have these 2, you keep it, and you cannot do anything with x plus 1. It still remains the same. You cannot simplify it anymore. So, and at this point, magic. Now x plus 1 on top, x plus 1 on bottom, and you can cancel it. You can cancel it. You have this right to do this cancellation. Now again, when you cancel by term, so this term actually creates this division problem. So when you x plus 1 actually cannot be equal to 0. You could do this off to the side, this side calculation. So your x actually cannot be equal to -1. Now, if you place x is -1 over here, you would have 0. That your fraction at this point has no algebraic meaning, since your denominator becomes 0. Now, moving on, and after cancellation, you write your final answers, and we will be left with just x minus 1 on top and 2 on bottom. So this x plus 1 disappeared. So, and again, if you plug in this -1 over here, nothing is wrong. It's totally fine, it's totally valid. But when you plug in your -1 over here, so it becomes 0. So that's why this -1 has to be thrown out, has to be tossed out from your domain. Of domain of the function, if you have heard about this, so domain of the function, and you can check out my other videos on how to find the domain of any function, any algebraic function. So just check it out if you are interested and if you are up to this. But I mean, in terms of domain, so this would be the domain of your function at this point, if it comes to this. I hope it helps you, and I have another episode 2, where I come up with little bit harder examples on how to simplify or reduce rational expression or algebraic fraction to its simplest form, and you can check it out. And also I have episode 3 on how to add, subtract, multiply and divide rational expressions. So if you're up to it, feel free to check it out. So train your brain, and thanks for watching. I know everyone hates maths, but if you like my video, just please hit like, share with your friends, leave the comment down below and subscribe so you will not miss my new videos.